Today we are going to start another property known as the flat and elongated particles. You know, we are discussing the different properties or the different tests required for the consensus property. So, and other of them is the flat and elongated particle. So first of all, as I explained to you flat and elongated particle, let me tell you, okay, this flat and elongated particle is actually related with length L, width W, and thickness T. Flat and elongated particle having the ratio of length to the thickness L by T. If length to the thickness ratio, its value is also mentioned that its value should be 5:1. If we have the particles which is exceeding this limit, are grouped into flat and elongated particle. Here I would like to tell you, these flat and elongated particles, if we are going to develop hot mix asphalt, let me tell you, if we are going to develop hard mix asphalt with the aggregate more flat and elongated, just keep it. We are going to develop this hard mix asphalt with the aggregate which are having more and flat and elongated. To keep this thing in mind, these flat and elongated particles at the time of the construction and during the service, they are going to disintegrate. Please let me repeat it again, that during the construction or during the service, they are going to disintegrate. When the disintegration is being done, to keep this in mind, the properties of aggregates are being changed. So that is why these flat and elongated particles are no more required. But you know, we cannot get rid of this flat and elongated particle, but Superpave has set its limit. Mix has set its limit. Clear? Now, this limit depends upon traffic level. As I have explained you many times about our traffic level, okay, there are many traffic levels, but out of those many traffic levels, our own example is heavy. Means the range of traffic is 100 million. In such type of the traffic, its value should be less than 10%. So this is the condition. Okay, when we are dealing with a heavy traffic, where the flat and elongated particle F and E, let me write down for your understanding, that elongated and flat particle amount should be less than 10%. So it means this value has been specified. Now the next question arises that how we will find out these flat and elongated particles. After giving this brief introduction that what are the flat and elongated particles, how much is the specification limit. Next, I would like to tell you method for the determination. This method is given by ASTM D4791. We will use this standard when we have to determine flat and elongated particle. Clear? So this is the standard. According to this standard, we are going to determine flat particles, flat and elongated, not separate, flat and elongated. Now, how we will determine it? I will just give you just brief introduction because I will not waste more time over this one. These flat and elongated particles are determined by proportional caliper. These values are determined by proportional caliper. Now, how this proportional caliper looks like, I will just make it rough sketch. It's like this. Here this point is fixed, known as point A. Here this point is fixed, known as point B. And this is the pivot point. This is the pivot point. And it is set in this ratio. Now, let me first of all tell you about its operation. We will keep one particle lengthwise at this point. This is the lengthwise. Because we will open the proportional caliper according to the length of this. This is a piece of aggregate. Now, this position will then remain fixed. After fixing this length, we will take out this particle. Then we will try to check this particle thickness wise in the other end. So there are two conditions. Either particle will pass, it is passing, and second condition are not passing. Let me tell you again. This particle is fixed lengthwise in this proportional caliper. After that, caliper position remain undisturbed and it is made to pass thickness wise along the other section. So there are two possibilities. Either this particle are passing, either it is not passing. So passing particles are placed at one point and not passing particles are placed at another point. So X is passing, Y is not passing. So this is the function of this proportional caliper, that how it will function, how we will make this one. Now next, from where we will take this aggregate? The question arises, from where we will take this aggregate. Now I will explain you briefly from where we will take this aggregate. Let me rub this one. You know that you have the sample of this material known as the representative sample. Take the sample of aggregate. To be used for the development of mixed design. Do sieve analysis. After doing the sieve analysis, make the group of passing and retain on other. Sieve. Consideration only for the course aggregate. When we say the consideration only for the course aggregate, then let me tell you that how it will be. You know, we are dealing with a bearing course. In this bearing course, our maximum size of aggregate is taken as 19 mm, then 12.5 mm, 9.5 mm, 4.75 mm, 2.36, 1.18, 0.6, 0.3, 0.15 and 0.075. These are the sieves. How much material is passing through this one? These are the sieves. Let me write down it by DI. And let me write down passing. Here I assume that 100% is passing, 99% material is passing, here 82% material is passing, 63% material is passing, 43% material is passing, 24% material is passing, 12% is passing, 7% is passing, 4% is passing, and 3.5% is passing. So this I have just written an estimate value. From this value, as I have already told you, that my consideration is only up to this point. Why? Because I have to consider only and only course material, and up to 4.75 I am going to take this material and I will tabulate it. Then I will try to explain you that how we are going to calculate the amount of flat and elongated particle. Now this table will remain over here. I will make the group in such a way that it will be easy for you to understand. Like 19 mm is passing and 12.5 mm is retained. It's my group number 1. 90 to 12.5. Similarly, the material is passing to the 12.5 and it is retained on the 9.5. And at the last, from this 9.5, certain material is passing and it is being retained some on this one. Now, as I see this table, from 19, 100% passing, here 99%. How much is the percentage retained over here? 1%. From this 99 up to 82% passing, how much material is retained over here? 17%. And over here, 82% is passing and 82 from the 63 passing, how much is retained over here? 19%. So this is the percentage of original. From this representative material, I will take certain amount in gram. Let me tell you, because here we have taken some material in one pan, here it is the material in second pan, here this material in third pan. From these material, I am going to take the representative sample. You know, this is a bigger particle. That's why I am going to write down here, suppose 1200 gram of the material is taken as a sample in order to check flat and elongation. Similarly, over here, 900 gram of this material is taken, and after that, this 700 gram of this material is taken. When I have taken these representative sample, Now, this material, each particle one by one, will be made to pass to the point A and B. Here I will see that how many particles are flat and elongated, means those particles who has been passed through point B, which is related to the thickness. Here I assume that 90 gram of this material has been passed. It means 90 gram this material is having the characteristic known as the flat and elongated. Similarly, within this 30 gram of this material are flat and elongated, and here 25 gram. Now from these value, if I try to find out the percentage, it would be like this one, 1200 90 divided by 1200 into 100. It will come 7.5%. Similarly, I will do it over here. It will come 3.3%. And next, similarly, if I do it over here, it will become 3.6%. It means from this 1200 material, 1200 gram material, 7.5% are flat and elongated. Similarly, over this 900 material, 3.3 are flat and elongated. Over here, 3.6 are having these characteristics. Now, how much is the total percentage taken over here? If I make it add this one, its value become 37. With respect to this percentage, with respect to this original percentage of this material, try to understand. With respect to the original percentage of this material, if I will calculate the weighted percentage, is calculated by the relation of this and by this. Clear? We will calculate the weighted percentage of this material, this into this by 100. Its value comes out to be 0.075. Like, I will show you one example how I have calculated this. 7.5 multiplied by 1 over 100. This formula is applied in all. Its value comes 0.075. Its value comes out to be 0.6 and its value comes out to be 0.7. When I will add these value, after adding all these percentages, I am going to get 1.38. Clear? So, when I have calculated the weighted percentage, from this weighted percentage, I would like to calculate the amount of this flat and elongated in this blend. Flat and elongated particle percentage in blend. Here what will I do? I will take the ratio of this value, multiply by 100. After calculating, this value comes out to be 3.7. But specification limit for my traffic level is 10%. So this thing clearly shows that it is the maximum. So this thing clearly shows that 3.7 is far less than 10%. So it means whatever the mixed design I have to develop, whatever the source of aggregate I have taken, it is going to satisfy the condition of the flat and elongated particle. So it was just brief introduction. I am really sorry I cannot perform it on myself because just I have to explain it to you for your understanding. So if you have any doubt, please let me know and I will try to further clarify it. Thank you for seeing my lecture.